This is section 7, chain rule, example 2. So now we're going to use the chain rule again, right? And we're going to find an equation of the tangent line to the graph of f of x equals the square root of 2x plus 1 at the point 4, 3. And we know we're going to use the chain rule because 2x plus 1 is inside that square root. Right there. That's the inside function. Now to find the equation of the tangent line, you need two things. You need the slope and you need the point. They give us the point and they give us the function to be able to find the slope. So the first thing we need to do is take the derivative because the derivative gives us the equation for the slope of the tangent line. F prime of x. Now remember, the way that I could rewrite this is 2x plus 1 to the 1/2. So when I take the derivative, I'm taking that 1/2, moving it to the front, we get 1/2. The inside stays the same, 2x plus 1 to the negative 1/2 times the derivative of the inside, which is 2. Now, this is where knowing how to change things so that they're prettier is going to be handy. So I'm going to go ahead and take this and rewrite it the way that I would like to see it if I have to use it, because I'm going to have to use it to find the slope of the tangent line at the point 4, 3. So I'm going to rewrite this as 2 over. Now, the 2 on top actually comes from the yellow 2, right? Because it's just 2 by itself. The 2 on the bottom comes from the fractional 1/2 that's in front. Then I'm going to have the square root of 2x plus 1. I change it to a square root because I know how to deal with square roots better than I know how to deal with half powers. And I know they're the exact same thing, but in your head, it tends to be a little bit easier to look at a square root and say, oh, I know how to take the square root of 9, or I know how to take the square root of 16, okay, instantly just by looking at it. Now, we're going to go ahead and find f prime of 4. I'm finding f prime of 4 because it asks me to find the slope of the equation of the tangent line at the point 4, 3, and x is what our function is in terms of. So I need to take the x value of the point and plug that into the derivative. That's going to give me the slope of the tangent line, at least for this type of problem. So I'm going to have 2 over 2 times the square root of, what is that? 2 times 4 is 8 plus 1 is 9, so 9. Now those do cancel. And the square root of 9 is 3, so the answer is 1/3. But that's just the slope. To write the equation, we need y minus y1, which is 3, equals the slope, which is the derivative, times x minus x1, which was 4. And the number 3 and 4 both came from the point that they gave me. The 1/3 came from the derivative at where x equals 4.